All right, so you guys, we've got a pretty easygoing week because it's only 3 days, and after having the 4-day weekend, I was like, let's go ahead and spend some time reviewing from having such a long weekend, especially because it was, for me anyway, kind of like a 5-day weekend because I was super not feeling great Thursday, but definitely Friday. All right, so I had you guys work on your homework, yeah?
Yeah.
How did that go on Friday?
It was pretty good. We only did we didn't do like 5.4 and on, I don't think.
Yeah.
We haven't done it. Right.
But other than that, you guys feel really good about it.
Yeah.
Yes. We toiled.
We toiled?
We toiled.
Toiled.
Us specifically.
Okay. Are you feeling confident in your answers to the said homework?
I forget.
What I did.
Yeah, pretty good. Everyone was agreeing, I think.
No sick.
We did it all. Yes, that's good.
Like on a scale of 1 to 5, can you rate your confidence?
No, 11. 11, I was a little confused on what we were supposed to do, but like other than that, yeah.
We all kind of checked our answers together and arrived.
So you guys are currently operating under the assumption we all got the same answer, so we're probably right.
To an extent.
I don't think that's a terrible assumption. By any means. By any means. Okay. So what I had planned for today, we did last week. And then you worked on your homework. So we're basically kind of a week ahead.
A whole?
Well, this week ahead. We're this week ahead.
All right.
We're 2 days ahead. We're 2 days ahead.
It'll be fun.
No.
We could do 10 minutes of
I think I have a lot of final review put in there too.
You definitely, yeah.
I don't have
It doesn't even have to be the whole period, just like a little bit of trivia.
Okay, so this is what I'm thinking. I think right now I have the quiz planned for Tuesday, yeah? Over 5-1 through 5-4.
Still thinking today's Monday.
Yeah. No, this is like the best week. This one's like my favorite week.
It's actually
so much.
It would
If you
have
think
been
about it, then that means
if
we
I
had
didn't
school on Wednesday then.
if I didn't have an interview Saturday for a college.
But that's like,
Yeah. Because it was just, I just got the email yesterday.
this is great. This is good.
So
Guess what?
Yeah, some Ohio one.
I'll be thinking about you. I'll be sending you nothing but positive vibes.
Anna Grass also has one.
So I'll send you both some really positive vibes, okay?
It was a girl that to hear broadly.
Okay.
And she was
So
20 years old. And she was trying to read a lot. It was great.
all right. So knowing that we are where we are, I really wanted to do some practice with the Riemann sums, more so. And there's some things that are on the quiz next week that are not necessarily well represented in the homework packet. So I want to give you guys some of those practice problems.
I appreciate that.
So here's kind of what I'm thinking. I kind of want to do 5-4 today and maybe tomorrow if we need to, and then leave Friday prep for the quiz. Friday, you tell me, what do you want? And we'll prep for the quiz on Friday. Do you guys see what I'm saying? So I want to kind of make Friday that work day.
What will Monday be then?
I don't know yet. Well, I mean, theoretically, I kind of want to move the quiz to Monday. But that still puts us as, like, weird places ahead.
Do we need the block day for it?
No, it's not that long. Is it? Is it? I didn't.
That's what I'm feeling. I'm feeling a little like 10-minute trivia sesh.
Today?
Yeah.
No, you just had, like, a 5-day weekend from me. Like, you've had plenty of rest and relaxation. If you're going to have an easygoing day, it's not going to be after a long weekend. You don't need it right now. Okay, so why don't we do this? We're going to do today and tomorrow 5.4. And then on Friday, I will take requests for practice problems that are going to be on the quiz. And maybe, on Friday, I'm just going to have you guys finish out the homework packet, have me check the homework packet, you tell me what you want review. And then on Monday, what I'll do is create, over the weekend, I will create stuff based on your guys' requests.
That's a plan.
Does that seem like a decent enough
And
plan?
stuff that's like not represented in the homework too.
Yeah. So we're looking at today. So I'm going to do this by date because I'm a mess otherwise. So today we're going to do start 5.4. Tomorrow we're going to do 5.4. Friday we're going to do homework, study, give Meister review topics. You guys give them to me. And then we'll do on, lucky the 13th, which I have as what we're going to be doing here. Okay, so that's still going to work. On Monday the 13th, you guys will have, you'll do the review problems that I create over the weekend based on your requests on Friday. Does that feel like a... And then on the block day, that 14th, you guys are going to take quiz 6. And you're not going to get the whole class period. I'm going to start USEP, which you guys hate. Everybody good?
Yeah.
If you have stuff since you're not going to be here, if you have stuff you want me to do, you just have to communicate it to me sooner.
Yep.
I probably will look at doing that either Friday 6th period or Monday 1st period. Just kind of depends on how much I actually get done. All right. I feel pretty good about this. Do you guys feel good? Does this feel like it's setting you up for success?
Yeah, I like that.
Okay. So I guess
Fundamental theory.
I don't disagree with you.
I feel like we've read that.
There is more than one fundamental theorem of calculus.
Because everyone's always like, oh, this is the thing.
Is this?
There. Does that help?
No. I think
It
the
is. It's still fun.
Oh, I have to turn the TV on.
Yeah, that's what I was
Yeah.
explaining. Possible.
You guys, can we all pretend that this whole exchange went a little bit more smoother on my end? Man.
I would imagine.
All right, now we on the same page? Oh, you mean I just...
There it is.
Fundamental theorem of calculus. I think you guys already know this. It's just a matter of formalizing it. Yeah? All right. So now, all the fundamental theorem of calculus is a shortcut to doing the limit of a integral over an interval. Okay? Everybody good? All right. And so if I wanted to do this the limit way, just as a chance to do a quick review from last week, we would say, delta x is 1 over n, and ci is 1 plus k over n. And so we would take the limit as n approaches infinity of the summation from k equals 1 to infinity, k equals 1 to n, of f of ci, so that would be 1 plus k over n, the quantity squared plus minus 3, times delta x, which is k over n, 1 over n. And then we'd expand that out. We would have to use all those rules of summations to get our answer, yeah? Okay. This is so we don't have to do that. there's one question on the quiz where I ask you to do this. So you will have to do this limit at, because I say use the limit definition to calculate the integral. It's one question on the quiz. It will not show up on the test. Okay, but you will have to do it once. I do give you the summation formulas. Okay? Right, but instead what we can do is we can go ahead and integrate f of x to get capital F of x. And then if I'm doing this from a to b, I do f of b minus capital F of a and b and subtract them. You guys, I'm going to shut up now because I feel like you already know this. Okay? All right, so how do I integrate x squared minus 3? And if I didn't have the bounded interval, I would have to add a plus c. But what this fundamental theorem of calculus tells us is we're evaluating that from, I don't know why I wrote a -1, we're evaluating that from 1 to 2. Okay? And so what we're going to do to evaluate it from 1 to 2 is we're going to plug the 2 in. And subtract, we're basically going to plug both values in. And we're going to subtract the lower boundary from the upper boundary. Which is significantly easier than doing that limit notation. Okay? Now, if you use that limit definition, if I ask you to do that, can you check your answer using this? Absolutely. But I'm going to look for the appropriate support that you use that limit notation. Okay? So, let's see. This is 8 over 3 minus 6 minus 1 over 3 plus 3.
It goes to -2/3.
Huh? You got -2/3? 7/3 minus 3 is in fact equal to -2/3. I'm good with that. It's a little bit easier, I think. And your calculators can calculate this for you. I would expect to see the appropriate support, which would at least include maybe this statement and like any combination of these two before you get your answer. Okay? So if you just give me the numerical answer because you just plugged it in your calculator, that's probably not going to be sufficient. There are times next semester where that will totally be sufficient because the work is actually coming up with the integration statement. Okay, but for right now, I want to see some support. Reasonable? Okay, so let's look at this one. How do we do this one?
It's just
The integral of secant squared is tangent. Evaluated from pi over 4 to 0. So we're doing the tangent of pi over 4 minus the tangent of 0. What is the tangent of pi over 4? 1. What's the tangent of 0? 0, and we get 1. Again, can you use your calculator to check your answer? Yeah. And does everybody know where to find that in the calculator? Math, and it's either, it's 9. Okay, math 9.
Mine's 0. No, it's not. No,
Math 0 is the summation.
Math 9.
Is everybody good? And I'm totally fine with you using your calculator, but again, I need to see the support that you integrated the function. Okay?
Do they have secant?
No, you would have to do 1 over cosine and then square. There might be secant hidden away.
Yeah, there's 2.
I feel like There is a place where you can find it.
If you check the catalog, there's no secant.
There's no there. That's what I'm doing right now.
Yeah, there's no secant.
Yeah. Then no. Yeah. You have to do 1 over cosine. Okay. All right. All right. Let's look at this one. You guys don't have to do this, but it really helps me to think of this way. Can you tell I'm like second guessing myself today because you're giving me the.
You make a funny face. Where you're like,
I just have to think a little bit harder. And what I'm doing is I'm doing the derivative to make sure it works. And so let's see, that's 2 times 4 to the 3 halves minus 2 times 1 to the 3 halves. 16 minus 2 is 14. Ooh.
Yeah, 64.
What do you think about this one? Natural log of x. Evaluated from e to 1. What's the natural log of b?
1.
What's the natural log of 1?
0.
Woohoo! See, this is fun.
Yeah. For now.
Wait, there's much more than.
We'll see what it gets to.
It's harder.
You never know what. And then we're done with calculus.
Yeah, that's it. That's it. That's how that goes. Yeah. Ooh.
Oh wait, that's the.
Oh wait, it's
This one's not bad. This one looks a lot worse than it
I just
is.
don't remember the rule for absolute value.
well, it's only on the positive side.
Oh.
There's something there.
There's something here.
I
Yeah.
can't remember what it is.
Anybody wanna think this one through with me? Okay, you guys are the worst.
You can't give us an option.
can you speak fast or do you?
So just for kicks on this one, we all saw the absolute value and went, right? I saw you guys do it, right?
I just don't remember. What it is.
Why?
Because it's something different.
Because absolute value is messy. You have to think it through a little bit, okay? Whereas all of these other ones are continuous functions and differentiable all the way through, yeah? Absolute value, not differentiable, so it has some like messiness to it. Everybody good so far? Okay, so what I think might be valuable is what does the graph of this look like? What does the graph of the absolute value of 2x minus 1 look like? You know it's messy, yeah? It's going to be V-shaped, I agree. I'd probably want to know a little bit more about that V.
Oh, there's a corner. Oh, I guess it's kind of given. It shifted right 1. Is it not shifted right 1?
It would be right 1 if this 2 weren't here. The vertex of the V is when the inside of that absolute value equals 0. Because it happened, like 0 is the boundary between when we do something with the absolute value and when we don't.
1.5. Or wait.
Is that okay? So this is a V that kind of looks like this.
Oh, so it's not differentiable.
And this is at the the x-coordinate where that would equal 0 is 1 over 2. Because it's going to happen whenever the inside of that absolute value equals 0. So for what value of x does this equal 0? We saw we get 1/2. Everybody good so far? And essentially what we're finding are these two areas. We do have some slight issues in that I did not necessarily draw this to scale. We don't know. In fact, we do know that those are not right angles. We could probably do this using an area model, but I'm going to show it to you using the definite integrals to kind of... All right, so when I look at this side of the graph, what is the... If I'm only looking at this piece, what is the equation of the graph? Negative 2x plus 1. Are you guys comfortable with that? Okay, so for the first half of the graph, from 0 to 1/2, I'm integrating negative 2x plus 1 dx. So essentially, absolute value is a piecewise function. So and at this particular one, the separation from the first piece to the second piece would be at x equals 1/2. So we're just going to write this as two separate integrals. Is this feeling decent? So yes, absolute value requires us to think a little bit differently, but really we're just looking for where is that split, and then we're making it two different pieces. Let's see, so negative x squared plus x evaluated from 1/2, or from 0 to 1/2, plus x squared minus x evaluated from 2 to 0. 0 to 2, technically. I always say those backwards. How are we feeling?
The second one isn't 1/2 to do?
Yes, thank you. So I think we get 1/4 minus 0 here, plus 2 minus 1/4, plus 1/4.
Negative 1/4.
Don't you,
No, it's a plus.
don't you have to add a half too?
No, it's a plus. I had 2 plus 1/4.
Yeah.
In the end. Like there's more.
All right, so I would do, I'm doing 2 squared minus 2 minus 1/2 squared minus 1/2. Likewise, like that positive 1/4 on the first, this positive 1/4 came from doing negative 1/2 squared plus 1/2. Okay? And so 1/4. So 2.5. Now, if you actually drew this out on graph paper to calculate it, so that you could find the actual length and width of, or base and height of each triangle, I would be totally fine with that. Okay? But what is this value? I'd probably need to see either some precise graphical support, like you drew it with the actual slope and all that kind of stuff. Okay? Do you guys see what I'm saying there? Right on. Funsies, right? Ooh. M.A. Be Chiquita? Do you guys call it Be Chiquita and Be Grande? No.
Oh, I think I got some nostalgia from that.
I
Okay.
feel like Be Grande was like a B versus Be Chiquita
Yeah.
is a V. Because they're both the same in
They sound-
Spanish. They sound the same.
exactly.
Be Chiquita. Little one, the little bee. Oh, wow. Have you guys, this is lovely.
Yeah,
The color coding looks a little bit better. Yeah.
we just got the flame. It's a shame.
All right. So the average value of a function is essentially the average value of the y values. Okay? But like this one we can kind of see, it's not symmetric, but we can kind of see that this area right, this and then this area are like the same, right? But in general, the average value of the function is where the area above the line and the area below that value are the same. Okay? Here we can kind of see them as the same because they're like practically the exact same shape, right? Not all functions have that nice like symmetry. Okay. So, and if you think about what there is that line, that horizontal line would have to cut through the function in order to have the same amount of area above and below. Is everybody with me? And so we can say the area of this rectangle is equivalent to the area of the function. Does that make sense? All right. And what's the area of this rectangle? Well, it would be base, which is b minus a, right? Times the height. What's the height of the rectangle? F of c. And all this mean value theorem for integrals says is that c is somewhere in the interval, as long as it's a continuous function. Okay? And so, but we also know that the area of the function, so the area of the rectangle equals the area underneath the function, right? Well, the area underneath the function we already know is this. And we know that's equal to the base times the height. That's where that model comes from. And there's two ways I could ask you to use this average value of the function. So f of c is that average value, and we know that it's just the value of the function at a specific point in the interval. Maybe more than 1 point. There could be 2 or 3 points. It's possible. Okay? So if I ask you to find the average value of the function, I'm basically asking, so if I'm asking you to find the average value, I'm saying, well, what is f of c? Because that's what the actual average value is this line right here, f of c. And so to do that, we can kind of rearrange this and divide through to find f of c. And you guys get what I'm saying, yeah? So it turns out we have a formula for the average value of the function. You just do 1 over the width of the interval. That's like the same as dividing the width of the interval away, so you're just getting the height of that rectangle. Okay? So if I were to say find the average value of this particular function on the interval 0 square root 3. Okay? So when, first of all, let's just kind of look through this picture, yeah? So if I plug in 0, I get -1. If I plug in square root of 3, I get 2. Yeah? This is a x squared function, so it's going to look something kind of like this, because it's a parabola. All right. Now, so if I ask you to find that average value of the function, what we're going to do is we're going to say, what's the width of my interval? What is that distance? Times the integral of the function. Now, are you guys with me that if I plug in the 0, everything's going to cancel out?
Mhm.
So we're really going to focus on just plugging in that square root 3. Okay? So I'm doing 1 over root 3 times 1/3 times the square root of 3 to the third minus the square root of 3.
Oh, that's what I forgot.
Now, I don't know about you guys, but my next step, I want to multiply through by that 1 over square root 3. That's probably not what you guys want to do, is it?
I mean,
I don't think it's that much worse.
yeah, I mean, do either.
You could do either. I think it's easier for me to reason through that if I divide everything by square root 3 instead of doing this, that I can take this down to a 2 and this whole term becomes a 1. So now I'm doing 1/3 of the square root of 3 squared minus 1. For me, that feels a little bit easier. Which is, by the way?
0.
So here is my average value of the function.
Square root, not cube root.
Everybody good? Now, the other thing I might say is which values of x are guaranteed by the mean value theorem of integrals, which essentially is we need to find the value of c that makes it equal 0 because that's the average value of the function. So we want to find the value for c that makes f of c equal to whatever this answer is. So then I would do 0 equals x squared minus 1. But the value of x we're looking, so technically to solve that we would get x equals plus or minus 1, but negative 1's not in the interval, so we don't worry about it. This seems like a good stopping place, and then we'll finish these out tomorrow.